Okay, so we're gonna keep going with the matricy stuff, but now we're, instead of doing it for like size change and scale change, now we're gonna do it for reflections, and then we'll also get into rotations. Today's just reflection stuff. So just a reminder on the reflection notation, reflection is always a lowercase r, and then whatever the little sub thing is there, that's the line we're flipping over. So like in this picture, it would be line M, so that's why it's a little m there. In the parentheses is always our original point, so like A, that's called the pre-image before we do any movements, and then the A prime would be our image after we do the flip over that line. So we're going to do some different ones here. So we're going to flip over the y-axis first. Y-axis is our vertical line through there, right? So what I'm going to do is I'm just going to make up some random point here, like I'm just going to make my A 5, 3, and I'm going to graph that. What's my ordered pair going to be if I flip over that y-axis? If I take that point 5, 3 and I flip it over the y-axis, what am I going to be at? Negative 5, 3, right? So I would go, instead of going to the right 5, I'm going to go to the left 5, but I'm still at that height of 3. So my A prime would be at negative 5, 3. And if that's difficult for you to remember, or you're doing it with like stuff that's like not on a graph, your x value is always going to switch signs. Okay, so whatever your x value is, it's just switching to the opposite side. So if it started negative, it switches to positive. If it starts positive, it switches to negative. And then if we multiply by this matrix out here, take all our ordered pairs times this matrix, that will give us a reflection. It'll take all those points and reflect it. Okay, next one here, flip over our x-axis. So we know our x-axis, that horizontal line going across there, right? I'm just going to keep the same point A as 5, 3. Okay, what's our ordered pair going to be if we took 5, 3 and flipped that over the line? Not negative 5, negative 3. So it'd be like 5, negative 3. Yeah, so we're still going out 5 to the right, but instead of going up 3, we're going to go down 3. Thurston, you want to shut the door? So our A prime would still be out 5, but instead of up 3, it would be down 3. Thank you. And then looking at what we got written on that bullet point there, our y value is always going to switch signs, which you can see is what happened there, and then that's our matrix that goes with that. And remember how we talked about the other day, when it's negatives, that actually does a reflection instead of like making it bigger or smaller. So that's why that's that, and then the 1s are in there because that doesn't change the size of it at all. Next one here, do you guys remember what the y equals x line is? So what it is it's a diagonal that basically has a slope of 1 and a y-intercept at 0, 0. Because if we had like y equals mx plus b, and we have y equals x, wouldn't our slope be 1 and our y-intercept be 0? Yeah, so that's why that line goes through 0, 0, and then it just goes up 1 over 1, so it's basically just a diagonal right through there. So if I keep that A point at 5, 3, and I flip over that line, where do you think I'm going to end up if I flip over that line? Not into the negatives, because that'd be over here. So if we're flipping over this line, it's probably up here somewhere. 3, 5, yeah. So if you look up here, our x and y are going to always switch spots with each other. So our A prime, the 3 is going to go to the x spot, the 5 goes to the y spot. Okay, so they just switch places with each other. So it would be 3, 5 as our A prime. You can kind of see there how that appears like it flips over that line. Or again, you could use that matrix, and notice on that matrix, see how the 0s are in a different spot then, and then the 1s are in a different spot. That causes the x and y to switch places when we do our multiplication, because instead of multiplying by your x value here, which is like your first position, it actually multiplies by your y instead, so that's what causes them to switch. Okay, cool on that if I flip? Okay, so we just got one more to do, and then we'll do an example of that. So this is the last graph one to do. Okay, so let's take a look at this one then. So the last one here, we've got reflection over the y equals negative x line. So that's basically a diagonal, but instead of being positive, our slope is a negative 1, so you're just going the opposite way. But again, it's a slope of 1, so it's kind of going just straight through there, and it's going to go through 0, 0 again because the y-intercept's 0. And we'll just keep that A point at 5, 3. That graph. Okay. Thoughts on our A prime here when we flip it? Yeah, so basically when we do this one, it's going to flip down here somewhere. It's going to switch the ordered pairs around, so the x and y are going to switch again. So switch to the 3 in the front and the 5 in back. But they're also, if you look back up at that bullet there, they're also going to switch signs with each other, or with whatever it originally was. So if they both started positive, then they're both going to switch to negative. So they flip, and they're going to switch signs. So that would be negative 3, negative 5 would be right in there somewhere. And then you can kind of see how that looks like it's flipped over that line, okay? And again, if you had to do that with like a whole bunch of points and you didn't want to go through and do that by hand, you can just use that matrix there. And it's very similar to the other one we just did where it flipped over the y equals x, but they just switched to negatives. Okay, and then it says there your pre-image and image are always going to be congruent with each other. So like if you started with like an octagon or whatever, when you do all your flips, it's going to be the same exact octagon. Okay, so then we'll just attack our last one here. So if P is 2, 5, Q, 4, 7, R, 9, 1, find the image of that triangle under a reflection over the y-axis using matrices. Okay, so we're flipping over the y-axis. And I'm just going to graph out that original triangle there. So 2, 5, P, 4, 7, Q, 9, 1, R. Okay, so that's our original one. We're going to take that, we're going to flip it over that line. They want us to use our matrices there. So if we're flipping over the or reflection over the y-axis, what's our matrix that we use to flip over the y-axis? What's our matrix, though? Yes, we're going to do that, but what's our matrix?
-1, 0.
Yep, so it's going to be the one that it's -1, 0, 0, 1. Then we'll do that times our original points there, so P, Q, R, which would be 2, 5, 4, 7, 9, 1. Do it down here below. And then we'll kick out our P prime, Q prime, R prime. But yes, when we flip over the y-axis, what happens to our ordered pair? What switches? The x, and what happens to it? It becomes negative. So all of our x coordinates here are going to stay the same exact number, but they just switch signs. So if that was a +2, it switches to -2. +4 switches to -4. +9 switches to -9. What about our y values? They stay the same. Yep. So it would be 5, 7, and 1. And again, if you type that matrix out on your calculator, you're going to get the same exact thing as what we just got there when we kind of did it by hand out. You guys need a refresher on the calculator stuff? You got it? Got it, okay. Okay, if you need help with it later or whatever, just let me know. But yeah, so if you do have to multiply it out on the calculator, some of them it's easier than others. Like this one's not too bad to do by hand, but some of them it can get kind of confusing. But then we'll just go and graph those points just so we can look at it. So -2, 5, P prime, -4, 7, Q prime, and then -9, 1, R prime. Okay, and looking at our triangle there, does it look like it was flipped over that line? Absolutely, yeah. So, like I said, you can either do it by hand like that, or if it says using matrices, just make sure you write the equation out using the actual matrices. Okay? All right, so we're working on that book page for tomorrow, 259, 1 to 16, skip 14 and 15.